Hi everyone, welcome to GradeGuru. Today we are going to look into relative atomic mass. Most of us really know the definition and the way to calculate it. Okay, what is relative atomic mass? As we can see, it is the mass of an element of an atom relative to 1/12 the mass of an atom of carbon-2. And we can also see the equation that is normally used to calculate it. But not many of us, unfortunately, really understand what this actually means and what this is trying to tell us. And once we understand it, we can actually appreciate the beauty behind the relative atomic mass. So, to start off with, let's start with some example. Let's say this guy here is called Bob, and his weight is 70 kilograms. Now, what do we understand when we say someone's weight is 70 kilograms? What this essentially means is that Bob is 70 times heavier than, let's say this is an object, and this thing weighs 1 kilogram. Let's take another example. Let's say this is, let's call her Anna. Sorry, my drawing is not really the best. Anna is, let's say, 50 kilograms. And what this also means is that Anna is 50 times heavier than the same box above there. So I'm just drawing it again, which is also 1 kilogram. So what we are really trying to say is that whenever we are comparing some weight, we are actually comparing with relative to some reference point, as we can see with 1 kilogram. And if you can look into this picture, you can see that this is a vegetable vendor, and he is trying to measure the vegetables. So let's say this thing, let's say this is 2 kilograms. Whatever vegetables he has is less than 2 kilograms, but the customer wants 2 kilograms, so he is going to put more vegetables until we have 2 kilograms. So it's going to be on the same balance. So similarly, scientists also need to deal with measuring stuff, in this case an element, with reference to something. And scientists have chosen carbon-12, and we are now going to understand what that means. So let's say this is carbon-12. Okay, this is carbon-12. Okay, so you can imagine this is an atom, and it's carbon-12 atom. And what we are going to do is that we are going to divide. Okay, so let's divide it with 12 parts. You can also imagine that it's a cake or something, and we are going to divide it into, so there should be one more. So yeah, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 parts of this cake. Sorry. And now what we are going to do is that we are going to turn one part off there from this 12, okay? So if we do that, what this means is that this is going to be 1/12, okay, right? Because we have 12 parts in total. So what scientists actually did was they actually find the weight of this mass of carbon-12 through the use of spectroscopy. So what they found that this whole carbon-12 weighs 1926 into 10 to the power minus 26 kilogram. So scientists have found out, okay, this C12, through use some high advanced technology, they have found that carbon-12 actually weighs this. Now you can imagine this is a really small number, right? But we're not interested into the whole mass of an atom, but we are interested into 1/12 of it. And when we do that, and we basically have to divide this thing by 12, we find out that this comes to 1.6605 into 10 to the power minus 27 kilogram. So what this essentially means is that the mass of an atom, of 1/12 the mass of an atom, is actually calculated this. Now this, as you can imagine, it's a really, really small number. So if you see it's minus 27, so you can imagine it's going to be minus 0.00000, and I have to continue until it's 27. So it's a really small number, and scientists really like convenience. So when they did was they actually made this into an unit called AMU. So this is actually 1 AMU. So when we are talking about 1 AMU, what this means is that 1.66 into 0.5 and 10 to the power minus 27 kg. Now we know, we'll erase this. So we know the mass of nitrogen, it's 14, right? 14 AMU. And for oxygen, it's 16 AMU. And what does that mean? What this essentially means is that nitrogen is 14 times heavier than, what do you think? Is it going to be a carbon-12 atom? No, because we are measuring relative to 1/12 of C12 atom. Similar thing works for oxygen. We know oxygen is 16 AMU, so that would mean that oxygen is 16 times heavier than C12 atom. Now you may wonder, why did we choose the scientists obviously, choose carbon-12? Well, the main reason is because this isotope of carbon is stable and abundant. And that was the main reason why they chose this compared to, let's say, nitrogen, oxygen, because we could, if we wanted, do it for others. Like, for example, instead of a carbon-12 atom, we could have measured maybe nitrogen. We could have found the whole weight and then we would divide it, and then, just what we did for carbon, we could have done the same thing for nitrogen. But scientists chose C12 and we just stick to that. Now, we also know relative molecular mass, which is also important to understand, relative molecular mass. And before that, we need to really understand what is molecules. We know that when we add atom plus atom plus atom and so on, but of course we are not like hundreds of atoms here, what does it become? It actually becomes a molecule. This is similarly like, for example, when we have a group of birds, so we call it a flock of birds. Similarly like that, when we have a group of atoms, we call it molecules. Now, when we have to find the relative molecular mass, we just have to find the sum of the relative atomic masses of contained in the molecule. So, for example, let's say CH4. So if it asks you to find the relative molecular mass, what it essentially is asking is to find the relative atomic mass of C, which we know is 12, and hydrogen we know is 1. But since we have 4 of that, it's going to be plus 4. So it's going to be 16 AMU. Now, we could also, again, think 16 AMU. What does it mean? It means that's 16 times heavier than the mass of an atom of 1/12 of it. So that's what it essentially means. And if it asks you to find what is the actual weight, we could also give it 16 times into, and if you remember the mass of an 1 AMU, it actually is 1.66 into 10 to the power minus 27 kilogram. But yeah, we are not really bothered with this. We just mostly want AMU. Now we have just 2 questions to really understand. Okay, do we really understand this concept or not? First question, which one is not a unit of relative atomic mass? Now, if you remember the formula for relative atomic mass, it was just the mass of an atom, the mass of an element relative to 1/12 mass of a C12 atom. Now, if you remember, we have mass here and we have mass here. So it's going to deduct. So there should not be any units. Okay, so this is dimensionless. So AMU, we have chosen that as convenience. Gram per mole, can that be possible? Because we are dealing with gram here, and we're also dealing with, let's say, if we give mass a gram, and here we also give mass a gram, it's going to deduct. So this can't be done. Percentage, well, it could be. Dimensionless, well, that's also possible. So this is the answer. Gram per mole, because we know it's a ratio, and a ratio should not have any unit. If an element has a relative atomic mass of 16, how many times heavier is one atom of that element compared to 1/12 of a carbon-12 atom? Well, that means that it's going to be 16 times heavier, because whenever we know the relative atomic mass of something, it means that it's going to be heavier than 1/12 of a carbon-12 atom. So if it's 16, it should be 16. Don't get confused. Don't ever say that it's heavier one atom of a carbon atom. You always have to mention 1/12. It's pretty important, because if you remember the cake, we are dividing it into 12 parts, and we are only taking one part as a reference point. Thank you for watching.